All right, today we are going to look at inscribed angles. If you want to pause it right now and go get the vocab written down, I'm not going to go blank by blank here, just to save us a little time. I figure you can find that under the completed notes like you normally could. I'm just going to talk about an inscribed angle. So an inscribed angle is one that has the vertex on the circle. So B would be our vertex here, and then you'd have two chords that would make up the other part of it. Okay, so this angle B here would be our inscribed angle. Okay, whenever we're working with an inscribed angle, we also have to have its intercepted arc. Okay, its intercepted arc would be this one here because it's on the inside of the angle. That's what they refer to as the intercepted arc. Whenever you're trying to find the measure of an inscribed angle, it will always be half the arc. Okay, so if my arc measured 80 degrees, okay, that would mean that my angle would be 40 degrees. So if you knew the angle, you could double it to get the arc. And that will also always be the way that these inscribed angles work. Okay, so that's the big idea we're going to use today. There's some other things with it that we're going to look at, but I'm going to go ahead and jump into the examples and kind of go through each one of those with you. Okay, so if we look at example 1 here, first of all, okay, you've got two circles. Okay, for the first circle, you have, go ahead and draw this here real quick. So you have O as your center, and you'd have XN as the diameter. You have a Y out here, and you have an M over here. Okay, you're told that you have an 80 degrees here. Okay, the first one that it asks you to find is it asks you to find angle XNM. Okay, so X and M would be this angle right here. It is the inscribed angle if this is the arc. So that means it would be half as big, so it would have to be 40 degrees for that angle. The next one it asks you to find is arc XN. Okay, so if we find it, okay, XN, we could go either direction, remember, because it is on the diameter. Okay, and since it's on the diameter, it makes a semicircle. So that means that all the way around, it would have to be 180 degrees. Okay, talked about that one the other day. And then the last one it asks for is MN. Okay, well, if the whole thing is 180 and I've got 80 up here, that would leave us with 100 for NM down there. Okay, so those are the pieces they asked you to find on A. For B, they put a inscribed triangle. So they got the triangle on the inside. They've got your angles A, B, and C that you are looking for. Okay? They tell you that you have 140 on that top one and 100 right here. Okay, so they ask you to find A, B, and C. Okay, well, if you look at A is an inscribed angle. Okay, if you follow it out, you can see its intercepted arc is 100. That means it has to be half as big, which would make it 50. Okay, for B, you'll notice you don't have its arc, but you can find it because the circle equals 360. Okay, so that means there's 120 left over. Half of 120 would make it 60. And then C, its arc would be 140. Half of that would give us 70. Okay, so we'd want 50, 60, and 70 for A, B, and C. Okay, the next theorem that you guys have is talking about what if I have two inscribed angles that have the same arc. Okay, if you have two inscribed angles that have the same arc, then those angles are going to be congruent to each other. Okay, so if we look at a circle here, let's say you had angle A over here, and then you had angle B over here. Okay, but they're drawn so as if you notice they share this arc right here. Well, if they share the same arc, that does guarantee us that they will be congruent to each other. Because, say this arc was 70, then they're each going to be 35. Okay, so whatever the arc is, we know that the angles will have to be the same. Okay, so that's the idea that we're going to use for example 2. Okay, so for example 2, the first one is fairly easy. I'm going to go ahead and jump to B. Okay, because I think the first one you can figure out that they would both have to be 32 because they both share arc SR. Okay, I'm going to go ahead and jump to B. It's the same idea. Okay, but if we look at B here, you'll notice you've got angle T. Okay, going to arc SV. And then you'll notice you have your U that also goes to arc SV. Okay, so because they share the same arc, that means that we can know that these two angles are congruent, so we can set them equal to each other. Okay, so they tell you that T is 3x minus 5, and they tell us that U is 2x plus 15. Normal solving from here, you'd end up getting x is equal to 20 as your answer for that one. The next theorem we have is actually the reason that we were able to work with our right triangles, and we were able to say the hypotenuse and the diameter were the same thing. Okay? It is because of these inscribed angles. Okay? So anytime you have an inscribed angle that intercepts the diameter of a semicircle, if and only if the angle is a right angle. Okay? So if we look at this, what they're saying is anytime, let's say I have a diameter here, no matter which angle I make, let's say my inscribed angle is there, this would be 180, which would guarantee this would be a right angle, which gave us our right triangles that we did work with earlier in the chapter. Did a lot of Pythagorean theorem, okay, knowing that the hypotenuse and the diameter were the same. Okay, and that's really what you're working with here as well. Okay, but we're just going to be finding more angle measurements instead of actual side measurements here. Okay, so for the first one that they give you there, for example A, they're asking you to find A, B, and C. Okay, so if we look at A on example 3, okay, they give you your circle, okay, they give you the diameter, and they give you angles A, C, and B. Okay, they do also tell you that it is 70 degrees out here. Okay, so they're asking you to find A, B, and C. A is probably the easiest one. Again, if this is a diameter, which it is, then that guarantees us that A has to be 90 degrees. Because the semicircle is 180, half of 180 is 90. Okay, the C is pretty easy to find because its arc is 70, so that means that it has to be 35 degrees. Okay, lastly is the B. If you look, you don't know its arc, but you can find it because, again, if the semicircle is 180, that leaves 110. Half of 110 gives me 55. So we'd end up with 90, 55, and 35 as our three variables. Okay, the last one with B there. Again, gives you a circle. Okay, again, gives you a diameter. Okay, they tell you that angle F is 4x plus 2. They tell you angle H is 9x minus 3. And then you've got this one here. Okay, just like we've done before, we know a triangle, the three angles have to equal 180. We know this one's 90 because of the diameter. So we can go ahead and add all three angles to equal 90 degrees. Okay, so we can do 4x plus 2 plus the 9x minus 3 plus the 90 has to equal 180. Okay, do your normal solving from there, and you will end up getting x equals 7. Okay. So one more concept for us here, and it's kind of along the same idea. Okay, but now we're dealing with a quadrilateral instead of a triangle. But we are going to end up with kind of working the same idea, a little bit different though when it comes to a quadrilateral. Okay, so it doesn't matter what quadrilateral you have, it can look like anything, rectangle, square, something odd shape, doesn't matter. When you're working with it, you will know that the opposite angles will always be supplementary. Okay, and remember supplementary means equal 180. Okay, so if this one was A, B, C, and D, A and C together would equal 180. Okay, and then B and D would equal 180. So the opposite ones are always going to be supplementary to each other. Okay, so if we use that idea here for the next example, example 4, okay, we'll look at A here. Actually, I'll just kind of keep the same picture. We'll just change the variables around here. So for this one, they give you W, X, Y, and Z. Okay, they tell you you've got a 60 here and you've got a 95 here. Okay, they're asking you to find the other two angles. Okay, so again, you want to look at the opposite angles. So Z and X are opposite each other, which means they need to be supplementary. Okay, which means that my X is going to have to equal 120 degrees because they have to be 180 together. W and Y are also opposite angles, which would make them supplementary. Okay, which means Y must have to be 85. Okay, so again, opposite ones are supplementary, so we can set them equal to 180. Okay, we'll kind of do the same idea here with B. This one we'll just have to solve though. Okay, so if you look at this one, you've got GFAH. Okay, they give you expressions for G and A. G and A are opposite angles because they're across from each other. They're opposite angles. That means they do have to be supplementary. Okay, so I would take my 21x minus 2 plus my 38x plus 5. And that would have to equal 180 because they are supplementary. Okay, do your normal solving and you should get x equals 3 on that one. All right. So that wraps up our notes on inscribed angles. Again, if you missed anything, or I know I kind of do it a little hodgepodge because I do have to keep these videos 15 minutes or under for them to fit on YouTube. So I do kind of have to rush things sometimes a little bit, but the completed notes are on there if you need to go and look at those at all, if you did miss any of the vocab. Also, please make sure you do the assignments that are under the daily agenda, not the ones in your packet. We did make some adjustments, took maybe some of the more difficult problems off, just to help you guys here since it's a little harder to ask questions. If you do have questions though, you can send me an email and I will do my best to answer them through email. But like I said, we did try to take off some of the tougher ones to try and make things a little bit easier for you guys. All right, have a great day.